Hello and welcome to our first video on CMP 221, which is Introduction to Programming 2. And on this course you'll be learning about JavaScript for web development. On this video 1 we are going to be looking at principles of good programming, and as we have them here on the list. But before we go into these different options that we have, let's look at principles of good programming. Now, when we talk about principle, we are simply talking about rules or guidelines that you're expected to follow, and this time around, for you to be able to have good programs, or for you to be able to write good programs that can be maintained, programs that can be scaled up, and programs that are easy to comprehend. So with that in mind, let's go straight up to some of these principles that we need to keep in mind while building or while writing programs, so that our program can be easy to maintain, easy to extend, and easy to comprehend. Now, we have the following principle. First is single responsibility principle. We have abstractions. We have do not repeat yourself. We have keep it simple, stupid. You aren't gonna need it. Separation of concern, open and close principle, and then finally dependency injection. So let's go ahead and look at these different principles one after the other. Now first we have single responsibility principle, and in this kind of program principle it states that each component or each module of your application or your program should be given a single responsibility or a single functionality. Let's say you're writing a program to find the sum of two numbers and the difference of two numbers. You might be tempted to have a function that can find both the sum and difference at once, but following the single responsibility principle, you are expected to have a program, a module that could find the sum different and a module that could find difference on a different space. This way, if there's an issue with finding difference, you know the module to check or to go through. If there is an issue with finding addition, you know the module to go through. And the second principle here is abstraction, which is the process of hiding certain details and making public only essential information needed by the user. Now here, you as a programmer, you are expected to not bother the user with a lot of information. You only show them what they need to see, or you only let them know what they need to know, and you don't show them everything. For example, when a user is trying to log in and he provides invalid details, of course when you hit the database with those details, you're going to have an error because those details are not found. But you don't need to tell the user that an error actually occurred. Instead, what you would simply tell the user is invalid credentials, or invalid username, or invalid password, and you allow them to try again. So you only show the user what is important and hide any other extra details that the user will not need. Now going further, we have another principle: do not repeat yourself, otherwise pronounced dry, D-R-Y. And here, do not repeat yourself as a principle says you should avoid redundancy. The likes of control structures and abstractions should be used to avoid repetition in software development. So what does this point mean? Do not repeat yourself. Let's say you have a function or a piece of code that can do one task, and you need to perform that task in 5 different places. So instead of writing that piece of code in those 5 different places to carry out the same task, you are advised to utilize just one of the code or one of the function in those 5 different places. So instead of repeating yourself in different places, you are advised to reuse a particular component and not repeat yourself. Then we have the keep it simple stupid, also known as the KISS principle. And here you are advised to keep your solution as simple as possible, even if it has to look stupid. Making your solution very simple really have a lot of advantage. People can easily contribute to your project, and it's going to be easy for you to maintain because your solution is kept very simple. Then we have the you aren't going to need it or you're not going to need it, Yagni. And here in this principle, it's just saying that anything you're not going to need in your code or in your program should not be there. Alright? Anything, that portion of your program that does not have any function in the program should be removed because you don't need it, so there is no point keeping it around. Now we also have separation of concern. Now separation of concern is closely related to single responsibility because in separation of concern you are advised to make sure that each component of your application or your program is addressing a different concern from another. So there should be no two components of your program that are addressing the same problem. Each component should address a separate problem. Separate the problem into different sections or into different concerns and have different components of your solution take care of them. So it's more like still the single responsibility where you make sure that each component is taking only a particular responsibility. You're not joining plenty responsibility to one component to handle. And we have the open and close principle, and also the last one, which is dependency injection. So what does the open and close principle mean? In the open and close principle, you are advised to kind of have a roadmap before you even start implementing your solution, such that you have a detailed plan of things you would be adding subsequently instead of adding things when you are already done building, or adding things that you did not properly plan to add. So having a detailed roadmap would give you an idea of things you would be adding, like extensions that are going to come up, and this will really reduce the modification you would have to make, because as you're building you already have a plan and you would be working based on the plan that you already have. So this, they said, is also an important principle when you are building a library or a framework that others need to work on. Then the last one is dependency injection. Now dependency injection here is a process of creating dependent object that can get injection of others object from other class. Let me give you a scenario where dependency injection can work. Let's say you have 2 or 3 functions that carry out a task without asking the user to authenticate himself. And something happened, you do not want the user to have a free access. You want the users to always authenticate themselves before they pass those 3 functions. Ordinarily, it means you would have to follow these 3 functions and modify them individually. So imagine if the code you need to write is very much. So will you follow the 3 functions and modify them? No. So instead, you would write the solution in one function, and you would inject the modification into the 3 other functions that you have. So instead of modifying the 3 of them, you only write one and you inject it into those 3, and case closed. So you don't need to repeat yourself. You do not need to be having a lot of conflict because you would have one solution that is going to take care of 3 different scenarios. So that's it for our principles of good programming. I will see you on the next one.